Hi, welcome to Product Review by Robojax. My name is Ahmad Shamshiri. In this video we are going to do the review of this 10 to 55 volts DC 60 ampere continuous speed controller with forward, reverse and stop. So we can see the speed in terms of duty cycle up to 100%, and also we can change the direction of rotation of motor with the switch if needed. So when you turn it on and off, relays will control the direction. And let's see, counterclockwise. This module is now supplying 60 ampere, 112 degrees Celsius, 61 ampere. I purchased this from AliExpress and it is sold for around $15.38 with a $3.66 for the shipping. I'll provide you the link if you want to purchase it from our affiliated links. Here are the listed specification. The input voltage or the operating voltage is 10 to 55 volts. Here continuous current is 60 ampere and maximum current 100. So this is a tricky word that they played. If it is a motor controller, it should be continuous, but we will see. So this has forward, reverse and stop, and operating the pulse width modulation frequency, it says it is 15 kilohertz. Adjustable speed from 0 to 100% duty cycle. I'm gonna write a hack for this so you can control it using Arduino to control for other purposes, including the speed controller and the direction. Make sure to subscribe. The link will be below the video in the description. Now this is the module. We have two huge relays here. Unfortunately they've wrapped the model number and it's supposed to be 100 ampere, otherwise this should fail. And we have here a switch which turns on and off just the signal, not the power, so it will turn it off. And also there is a potentiometer or variable resistor here where you can control the speed. We will see the speed in terms of pulse width modulation in here. And then we have a switch, a three-way switch. At the middle it's off. One way is clockwise or counterclockwise, the other is in the other way. So you will find out which way works for you. There are MOSFETs and some diodes. And in here we have 4 terminals. These 2 terminals are labeled as minus and plus. This is the power and this is for your motor. For motor you will determine which way works at one direction for your application. The soldering and all these paths, they seem to be reasonably wide enough for this amount of current, but I'm going to test it and see under the thermal camera to see if it heats up. Length of the module is 120 millimeters. Width is 95 millimeters. And depth is 22 millimeters. Now let's have a look at the components. Let me remove the connectors. First, let's have a look at this piece here. This is the display driver. So there is nothing, they've cleared it out. Let's have a look at this chip. This is supposed to be 555 timer. (555), yes. So indeed that is the IC555. So as you can see, this is the 555, NE555. Let's have a look at this, the first one. And that is 7805. This is a 5 volts regulator, voltage regulator. Let's have a look at this chip. This is a back converter with this inductor. So this is a Schottky diode, and that's an inductor. This is a back converter, XL Semi, XL7015. This is accepting up to 60 volts and regulating it, and is sending it to this 5 volts. So this is always outputting 5 volts for the rest of the circuit. And now here I've connected my power supply to this point, and this motor is connected to these 2 terminals. And I'm going to just show you the start, stop and speed. And for the maximum load, I'm going to use electronic load to put 30, 40, 50, 60 ampere load on this, and we're going to test it. And here is the voltage that we have on these 2 terminals. So currently it's operating with that voltage, and here it is off at the moment. That's why it's 100% will make motor not to rotate, because this is turned off. So let me turn it on. So the motor was rotating clockwise, and let's see, counterclockwise. So it seems it has some kind of soft start. So it has soft start, it doesn't jump immediately, it goes slowly. Sometimes it goes slowly, sometimes quickly. You see, it's soft start. So now 7%, 18, 34. Let's change the direction. So there is no soft start. But it works very well. So let me show you now the minimum voltage. So 8 volts, 7.55, still it works. 6 volts will not work. The motor is off now. So 10 volts. What it means is, if you want proper operation, so if you want this to operate properly, 10 volts, and then you can go up to 55. And the voltage determines by this capacitor as well. If you go above the voltage, they will explode. Let me check them. So 63 volts. This is 63 volts. Above that, these will explode. Let me test it. Now I've connected this using these wires. My power supply is connected in here. This is connected to my load, to my electronic load, where I can select the amount of current, and you will see the voltage, which doesn't matter, but the current, you will see it here. Now I've set the current to 60 ampere. Let me turn it on. So this module is now supplying 60 ampere. Now 60 ampere, 100% I put on this. Let me turn it off and see how it works. So that is turned off. And this is the maximum current that this module can handle. I can see some heat, a little warming up of the device. Let me show you the thermal image. As you can see, it shows 73 degrees. If I put my finger exactly in here, it is 73 degrees. So, but the relay, the two relay that you see my fingers are in here, are very cool. So 73 or 80 degrees. So all these MOSFETs are getting hot. That is 95 degrees at this spot. This one. This is now 95, 96 degrees Celsius. So 106 degrees. Now this is heating up. This is very hot. Whew. So let me show you. 112 degrees Celsius. 111. 113 degrees. Now it's, I feel some smell. I turned it off. Too hot, very hot. Let me show you the current in here now. Right now, so 180 milliampere is consumed by this. And if I turn it on, it shows 61 degrees, 61 ampere. Let me turn it off. So 200 milliampere. Let me turn this around and let's have a look at on this side. I turned it on again, now it's on. 110 degrees in here, 120. It got very much hotter than before, 125. So I have to turn it off. So if it continues like that, this will need a fan, a cooling fan, to keep it 60, or maybe you have to add more heatsink, larger heatsink to dissipate the heat, or reduce the current. Here now I changed I set the current now to 50. Now 50 ampere is being supplied by this power. Let's go 40. Now 40 ampere. I set the current to 40 ampere. And let's leave it for a few minutes. Let's see what happens. Currently the temperature is 91 degrees Celsius. The hottest spot is exactly this one. So this is getting hot the most. So now the temperature is steady. And here is the room temperature to show you. 17.7 degrees Celsius. So keep in mind that in the hot environment this might not perform well. So 40 ampere is keeping it steady at this temperature. Still 99 degrees. Still this is getting hot. Now let me check the current. 39.7, here it shows. Thank you for watching. This was the review of this BLH 89278 10 to 55 volts 60 ampere DC speed controller and direction control. So far when I've tested it, this does not support 60 ampere, because as soon as you have 60 ampere the temperature is increasing continuously, so I stopped it. And at 50 also the temperature was increasing. At 40 the temperature was increasing, but at a very slow rate, and it seems that you can use it up to 40 ampere, but not more than that. The relays might be able to handle higher current, but this area, this MOSFET was getting very hot. The rest is very nice, the controller, the switches, and they're very responsive. So definitely it's a good product if you like the relay. And I will provide you the link to purchase it, so I can get also paid some commission. The link is below the video in the description. Please thumb up the video if you learned something, and make sure to subscribe so you get updates of my upcoming videos.